This video will help you understand how to find slope if you're given your points in a table. So here's an example of some points that are given in table form. And what you want to remember about slope, it's represented in many ways. Sometimes people say that it's the rise over the run. Sometimes people write delta y over delta x, and what delta means is change in. And then other people like to write this formula, y2 minus y1 over x2 minus x1. And I will show you how to think of it this way with the change in y and the change in x, and then I'll show you that you get the same result if you use this slope formula. So when you're calculating the slope, the rise is associated with the y values. I remember that because rise rhymes with y's. And the run has to do with your x values. And so if I'm looking at it in terms of how things are changing, one way to look at it is to think, well, what happened to my y value when it started at 10 and it went to 6? Well, to go from 10 to 6, it has to drop by 4. So I can think of that as subtracting 4. And if you look at this all the way down this table, from 6 to 2 is a drop of 4, and from 2 to negative 2 is a drop of 4. So it looks like our rise is negative 4. And then for the run, I do the same thing. I think about a number line and I think, what do I have to do to negative 3 to get to negative 1? Well, I have to move up 2, or I have to add 2. What do I have to do to negative 1 to get to 1? Oh, I have to add 2. So in each of these cases, my run is positive 2. So if I use the change in y over the change in x representation, then my rise is negative 4 and my run is 2. If I simplify that, my slope is negative 2. Now, some people like that method. Other people like to use the slope formula, and I just want to show you that that is the same calculation. So what you want to do if you're going to use the slope formula is you need to choose one pair to be 0.1 and the other pair to be 0.2. And for the sake of discussion, I'll just call this 0.1. So I'll call that x1 and this y1. And I'll call 1 the x-coordinate of 0.2, and this one is y2, the y-coordinate of 0.2. And so if you want to use your slope formula here, you're going to see that you're going to get the same thing. So if I do y2 minus y1, that's these y values subtracted, that's 2 minus 6. And if you do x2 minus x1, that's 1 minus negative 1. And if you do those calculations, you get negative 4 over positive 2, which is exactly what we had up here when we did the change in y over change in x. And so either way, your slope is still negative 2. Now let's look at a different table. Let's look at the delta y over delta x method first. So if I look at what's happening with my y's, again, your y's are your rise, and your x's have to do with your run. To get from a 1 to a 5, I have to add 4. And to get from a 5 to a 13, I have to add 8. That's kind of weird that those aren't the same. To get from a 13 to a 19, I have to add 6. So it looks like my rise is changing. Let's see what happens with the run. To get from a negative 3 to a negative 5 on a number line, I have to subtract 2 or go down 2. So that's minus 2. To go from negative 5 to negative 9, I have to subtract 4. And to get from negative 9 to negative 12, I have to subtract 3. So just like the rise was changing, depending on which points I used, the run was changing also. But what I want to show you is that when you calculate the slope, using a change in y over a change in x, you actually get the same thing no matter which pair you use. If I use this first change, the positive 4 and the negative 2, 4 divided by negative 2, well, that's a slope of negative 2. If I use the second change pair, I have a rise of 8 and a run of negative 4. Even though the rise is different and the run was different than what I started with, when I do the division and I simplify, I get the same slope. And in this case, for the last one, if I use a 6 divided by negative 3, I also get negative 2. So the slope is staying the same even though I'm choosing points that some of them are closer together than others. And that's actually a sign that this is actually a straight line. And if you wanted to, you could pick one of these points, call it x1, y1, and pick the next point and call it x2, y2, and you can use the slope formula and you will find out that you still get a slope of negative 2. Okay, last two here are just a reminder about some things that you may have learned about with some special lines. So let's look at this one. Remember, your y values have to do with your rise and your x values have to do with the run. And if I look at any of these are not changing at all in the y value. So your rise is 0 every time. And the run in this particular case seems to be 1. So your slope in this particular case is 0 over 1, which is 0. And a slope of 0 turns out to be associated with a horizontal line. So we don't have a graph here, but if I plotted these points, 5, 6, 7, and a y coordinate of 1, if I plotted these points, I would get points that were right next to each other in a horizontal line. And anytime you have a horizontal line, that's a slope of 0. And the last one is sort of the other extreme, where your rise does exist. Your rise is 1, or any other number for that matter, but it's your run that is 0. Your x values are not changing, so your run is 0. And so when you calculate the slope here, you get a rise of 1 and a run of 0. That is undefined. Be careful that you don't say that that's 0, because it's not. It's undefined. And if you think about where those points are, these are all x values of negative 2, but y values up at 4, 5, 6, 7, these points are all on a vertical line. So a slope of a vertical line is undefined. That's a quick review of how to find slope from a table.